Hello, right, here we go with a lesson on polygons. Now, polygons are many-sided shapes, poly meaning many and gon meaning shape, I guess. Right, so the first one we're going to look at is a triangle, and this is a triangle where all three sides are the same, and that's denoted by these little lines to say that these lines are the same length, and all three angles are the same as well. So all three sides and angles are the same, and this is called an equilateral triangle. Now when we have, that's not a very good one, is it? Excuse me. Okay, let's draw that one again. So when we have just two sides that are the same, like this, these two angles at the bottom are the same, and this is called an isosceles. And so this is two sides. Angles are the same. There's another triangle like this, and this one has got a 90-degree angle in it, and it's called a right angled triangle. And the idea of knowing all this stuff is that when you get puzzles and shapes and pictures and things, and you're asked to work out a particular angle, this helps you because you know the properties of the shapes you're looking at. There is one other that's a bit daft, and this is a scalene, and this is where nothing is the same. Okay, so then we have a look at four-sided shapes, and four-sided shapes are called, as a general thing, they're called quadrilaterals. All four sides of the quadrilaterals. This one is called a square, and a square, all sides and angles are the same as each other, so we could in fact do that. And then, because it's a square, all the angles in there are 90-degree each. So this one's a rectangle, and the top and the bottom are the same as each other, and the left and the right are the same as each other. Then we have this shape, which is called parallelogram, and this is parallel to that, and this is parallel to that. And parallel just means that they are never getting further away and never getting closer. And these are the same lengths, and when we have parallel, we put a little arrow in there, so we could actually make this a bit busier and put a double chevron there. So they're not only the same length, but they're parallel. Parallel lines don't have to be the same length, do they? See, that one's longer than this, but it's still parallel. And the thing about this is that these two angles are the same, and these two angles are the same. So we've got opposite angles are the same as each other. Right, come down a bit. We have this one, there's a little tail there, So this is called a kite, and these two angles are the same as each other, but the top and bottom are not. So we only have two angles the same. Next one there, we draw it like that. And it could be like this. And this is parallel to this, just the top and bottom. And that, these slopey sides don't have to be the same. So this is called a trapezium. Now, then we'll talk about lines of symmetry. Now, the lines of symmetry is which makes a symmetrical shape, which one side is exactly the same as the other. So if we have a rectangle like this, we have a line of symmetry which is always done with a dash, so it doesn't get muddled up with the other lines. So the top and the bottom is exactly the same, and we have a line of symmetry there as well. So the left and the right would be the same. A square would have a line of symmetry going that way and that way, just as the rectangle does, but also you can do the diagonal. So that has two lines of symmetry and this one has four. A triangle, now this will be an equilateral triangle, has a line of symmetry there, a line of symmetry there, and a line of symmetry there. Now when all sides, so that one's got three, when all sides and angles are the same, then we call it a regular shape. And when they're not the same, it's an irregular shape. Now, a regular shape has the same number of lines of symmetry as it has sides. So a three-sided shape that's regular has three lines of symmetry. The square, the four-sided shape, has four. And if we make a best effort to draw a pentagon, and this would be regular, so all the sides will be the same. We'd have 1, 2, 3, 4, 5. 5 lines of symmetry, and so on and so forth. Now, the thing about these two sets of shapes we've covered so far is that in the triangular shapes, no matter what kind of triangle it is, all angles add to 180. And in the four-sided shapes, no matter what kind of four-sided shape they are, all angles add to 360. Now, there is another kind of symmetry. See what I can do this. See what I can do this with it. Now, if I take this shape and rotate it 90 degrees, it looks like that. If I rotate it again 90 degrees, it looks exactly the same as what we started with, except it's upside down. So if I rotate it again, 90 is there, and rotate it again, 90, we're back to the beginning. So there are 4 positions for this. There's the first position, second, third, and fourth as we rotate. And this is rotational symmetry. Okay, rotational symmetry. Now, rotational symmetry has a number, and the number is, including the first original shape there, if we put a cross at the top, the cross would be there. As we rotate it, you can see that that side then is on the bottom because it's upside down, and then it's over on the left. Number 3 looks exactly the same as number 1, the original shape. So this has 2 rotational. Rotational symmetry has a value of 2 on this shape. If we take we've got a triangle, yeah, upside down triangle, never mind, that would be 1, rotate it 90, 2, doesn't look the same, rotate it 90, doesn't look the same because it's upside down, rotate it 90, now it's left to right, rotate it, oh, can't do that, it's and the last one was there, yeah. We started off with that. So we started off with this, which was 1. Then we went to that, which was 2. Then we went to that, which was 3. And that, which was 4. So there is only one position where it looks like the original, and that is the original position. So that has a rotational symmetry of 1. And when you're in an exam and you're looking for rotational symmetries, just put your finger in the middle there and turn the paper round until you work out how many times it looks like the original shape. They might give you a 5-sided shape or something like this. Right, okay, so now we looked at, I'm going to do a 6-sided shape. And the 6-sided shape is a hexagon. And what we would have to do, we're going to pretend that this is a regular hexagon because all the sides are the same. It's not a very good drawing, but all the sides are the same. And what we'd have to work out here is something called an external angle, something called an internal angle, and the sum of all internal angles. So you've got possibility of 3 things to work out here. Now the external angle, how do we find this? What is it indeed? We'll take each line and extend it like this. You only have to do it with one side, but I'll demonstrate with all. Now these there are the external angles. And because this is a regular shape, then all the external angles will be exactly the same as each other. Now, if you go round in a complete circle, yeah, you turn through 360 degrees. So we've got 1, 2, 3, 4, 5, 6 steps to complete 360 degrees. So to find the external angle, we just do 360 divided by the 6, which is the number of sides on the shape, and that will be 60 degrees. So there, I'll measure that, I'll label that one up as 60. Now, the internal angle is this one. Now, when you have angles that are on this straight line here, they will add to 180. because you're facing west, then you're facing east, so you've gone half the way round, so there will be 180. So in order to find that one there, which is the internal angle, you would just do 180, take away the external angle, which is 60, which is 120. So that's the internal. And the sum, because we have 6 sides, so we'll have 1, 2, 3, 4, 5, 6 internal angles, will be 6 times 120, which is 6 12 is 72, so it's 720 is the sum of the internal angles. And this method will work to find the external, internal and sum of any regular polygon. Polygon, there's a word, polygon. I haven't mentioned that since the beginning, gone. Right, any regular polygon, any many-sided shape. So we'll just demonstrate on a 6-sided shape so that we know that was a 6-sided shape. So let's do a pentagon, a 5-sided shape, and see where we go from there. 1, 2, 3, 4, 5. Regular pentagon. So to find the external angle, we do this. Now there's 5 sides, so you do 360 divided by 5, which is 72. So that one is 72. To find the external, to find the internal, we do 180 minus 72, which is 108. So that one there is 108. And to find the sum of all the angles, there's 5 sides, so we just do 5 times 108, which is 500, and 5 8s are 40. Yeah, so it works for all of them. Now, if this is something called an irregular pentagon, so this is an irregular where all the angles and all the sides are different from each other. So you can't just do 360 divided by 5 tells you the angle, because all the external angles are different from each other. So the only thing you can find here is the sum. Now the sum of all the internal angles is done in 2 different ways, and this is the first way. Take a corner and draw to the other corners to construct some triangles. Now you know that the sum of all the angles in a triangle is 180. So you've got 1, 2, 3 triangles. So you just do 3 times 180, which is 540. See, same answer as we did just now. So you can divide this shape up into 1, 2, 3, 4, 5, 6. To find the sum, 1, 2, 3. So we've got 1, 2, 3, 4 triangles. 4 times 180 is 720. So this is the sum of all the angles. This will actually work for a regular or an irregular. It won't make any difference. But this is the only way, well, this is not the only way, but this is how you find the sum for an irregular. Now, this leads us to a pattern. See here, we've got 5 sides and 3 triangles. Here we've got 6 sides and 4 triangles. So let's begin to formulate a little equation so we can have a triangle which has got sides and triangles. So that's got 3 sides and 1 triangle. A square would have 4 sides, 2 triangles, as we did up there. Pentagon will have 5 sides and 1, 2, 3 triangles, and the hexagon has 6 sides and 4 triangles. So there's always 2 fewer triangles than there are sides. So if we say the sides of the shape is equal to the letter n, n for the number of sides, and we go n and take away 2, then that will give us the number of triangles, no matter what the sides are. 6 take away 2 gives us 4, 4 take away 2 gives us 2, 5 take away 2 gives us 3. And we know that all the triangles are 180, so just multiply the answer there by 180. So if we have a shape here with, I don't know, 20 sides, we're going to do 20 minus 2 times 180, which is 18. I'm going to use a calculator for this one. 18 times 180 is 3240. Let's cursor there. 3240. So that is the sum of the angles in a 20-sided shape. So it doesn't matter how many. Right, let's have a look at see where we went from there. Now, we did find a lovely example from an exam question where maybe we had a 5-sided shape there tapped onto a so we've got a 6-sided shape and a 5-sided shape, and a perfect exam question is find that angle there. Now, because this is made up in the question, it would be made up of regular polygons. So to find this angle here between these two shapes, what you do is you cut them in half, like that. Cut them in half. And that there is going to be the external angle of the hexagon, and that there will be the external angle of the pentagon. So if we can find both, add them together, we've got the complete angle. So let's do that then. So of the hexagon, we've got 360 divided by 6 equals 60. So that will be 60. Of the pentagon, we've got 360 divided by 5, which is 72. So that bit is 72. And 72 plus 60, which equals 2, 3, 1. 132 degrees. So that angle up there is 132 degrees. Right, that's the end of that first part. The other part will be parallel lines. So I'll stop that there.